Alrighty. Waiting for start. Copy URL. Is this RNCPX? Okay, so it's in the URL too. I never actually noticed. And I haven't been pinging any of my stream notifications, people, because I'm stupid. Stream notifications. Boom. Alrighty. Get this out of the way. Make sure I've got chat open. Hello. Pretty good. I'm a little tired after eating food. I'm probably shouldn't be eating that much chocolate. How about you? Case. Let's see. Let's get ignore. The mic's still working. Good. Yeah, you mentioned 6, so I figured that was gonna be not good. But hey, not dead. We, I think, are in SEMA for imports. Keep that kind of small over here. And probably get legacy.h. Put imports down here. That looks pretty good. All right, so then we want knob run. AST, if I do syntax first, we'll get the tree. For test Laye import. Prove that I've done all the parsing for it, I think. Could not exec child process. Huh. Oh, because it's running through GCC. In what? There it is, okay. Well, I was running through GCC, that's weird. Oh, yeah, in pixels per inch. Yeah. I figured out you can make your monitor bigger in PP. I guess I just don't understand exactly what you're saying otherwise. Okay, so this works. Then SEMA has a lot of things that still need done. So we need to do a lookup through imports, which means we need to actually run imports as well. So this is saying right here on line 69 that we haven't found a declaration and we're not at the end of the thing, so we have some namespaces to look up. Yeah, this one's also a 1080. Hey, I know that guy. Okay, so before we can do lookups through imports, I mean, we could implement them, but we just don't have them yet, so we wouldn't see the results. We're going to need dependencies for things in a second, but again, we're not going to see that yet. So here, we have to go through all of our imports and actually import them, which probably means I need a better way to... Well, no, it's probably fine. Let me go take a look at what's in Laye. So here's the thing. I have this function for parsing a module, which just returns the module after semantic analysis. It's only a handful of lines of code, so I can probably just pull that out. Copy it. Copy pasta. Because all we need to do in SEMA is ensure that we've done sema on the child import. The biggest problem we're going to have is I want, if possible, to allow recursive imports. So, resolving dependencies. I don't want to hit a cycle error on imports if possible. There are some cycle errors that are a problem, but I don't want imports to have that problem. And I don't quite know the best way to do this just yet. So we can start by just iterating through all of our modules. I'm thinking about getting a 4K monitor because I just tested my MacBook to unbelievably crisp. Yeah, I want to get a bigger monitor. I also want to get like an ultra wide, but then I have to have fucking space for an ultra wide. And the last one I got sucked, so I've got to do more research and find a better one. I returned it like within the hour. It was terrible. Count is array count of it's not really array count of, but I guess it is. Module top level nodes I is less than my brain. Let's count I plus plus. We only want to do imports. Let's get the top level node. So I lost my semicolon in there. If top level node, what the heck? Find is equal to node import. Then we want to do something with it. We need to obviously sema import module or something. We might have a function just called import module that should return a module. Laye module imported module equals this. Do casts work yet? No. Like I said in Discord, they exist in the IR and sema can handle most of them, but they don't exist in the syntax yet. Honestly, casts would be a lot easier to do than what I'm doing right now, and I don't know if I have the brain power to figure out module imports at the moment. So maybe we take a bit of an aside to get me in the mood and we implement casts real quick. So I need to go into parser. That's a C parser I was trying to write. Parser for Laye. So I think I've got some brain fog I gotta overcome. I got water. Give me 2 seconds to get some water. Water acquired. As well as half a cup of soylent, because why the fuck not? Soy boy. So let's make a cast test. We don't have a cast test. Okay. Just have it return 0 for now. We want an R of Laye IR. Yes, I think. We're gonna try to tackle at least the general simple case for imports, and also Mr. Mugame wants casts, so I'm gonna try to set up a quick thing for casts, because Sema already knows what a cast is, so we can get at least the cases that Sema already has handled out of the way really quick to warm up my brain. So I know I'm gonna have to put some work into getting the best case for imports working, where I allow recursive imports and stuff correctly. So we've got the traversal of the imports from the top level of the module. We just got to implement parsing and sema for the imported module, and eventually be in a position where I'm not depending on modules for, like, I don't want to get to a dependency cycle on modules. So I just need to avoid doing sema on modules that, I mean, I probably need to, I've got this analyze for a module. I probably need to split this function up into analyze on a group of modules and analyze on a single module, so I can do dependency resolution on all of the modules in the hierarchy, build all of the top level references to those, and then do sema on each reference individually. So that's going to involve basically taking this whole function apart, which is going to be a little bit of work to figure out how to do correctly. I need to be in the right headspace for that. And I haven't programmed like all day. I've been very tired. So we're going to start with something simple and work our way up to it. And I made a mistake in eating, like, I don't know, a lot of chocolate. So I'm worried I'm going to just have a fucking crash. Anyway, let's see. What do we want to do for casting? I would love to do int to float and float to int casts, but we don't really support floats anywhere. They'd be really easy to do in sema, but I don't know. I mean, they'd probably be easy to do in CodeGen as well, because if we're just targeting LLVM for the time being, it would make, we'd need a little bit of extra work in implicit conversions, but we'd be doing the conversion anyway. Narrowing and widening would be fine. So if I did like an I64, we can start with that. I64 of foo, I'll just A, equals some value. It's not going to be compile time constant, so it's not going to be evaluated or anything. Then I can just say I32B is cast to I32 of A. And I can also just return B, and that should return 10. So that's a simple, we can add more later, but that's our simple case that we can just get working real quick. So in the parser, leave the test over here so we can all see what it's doing. In the parser, hell yeah. Yeah, I understand why people want to censor themselves. I don't give a shit on this channel. I'm not trying to be a family-friendly mass appeal, so I'm not gonna change how I speak to appease YouTube. There are probably cases where I would want to do that, but this is not one of them. Okay, I'm looking for parse primary expression. I don't want continue, I just want parse primary expression. So that's underneath parsing ifs and name refs, and there's primary expression. Okay. So I'll do it near the top. Case token cast. We want to next token, we want to expect. I don't think I have, I really should have a parser expect if I don't. Parser expect, I don't. I'm gonna write a parser expect. I want P, token, open paren is just this. And that'll simplify some things. We can just do this, and do this. Now let's go parser consume, not this, parser consume. And we'll implement expect in terms of consume. Static bool, Laye parser expect, Laye parser P, Laye token kind, if, oh god, all the wrong buttons. Oh, actually, hey, hold on, give me 2 seconds. Speaking of all the wrong buttons, that just reminded me that I set up a thing. If I do this, there's my keyboard. Ta-da! I can leave my keyboard down here. I could also turn on ye old face cam on my laptop. I got the both of these here. I can do that if I wanted to. It's not nearly as correct, but you can see my fucking hairy face. It'll cover up a lot of the screen, so I wasn't planning to do it on streams, but hey, I set it up so I could turn it on if I wanted to. Bop, 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 bop. Why is the chair blue? What do you mean, why is the chair blue? Wait, do we gotta talk about my chair? The chair's just blue. Fucking blue. I don't know what you want. I'll leave it on so you can see my blue chair, I guess. It didn't come in pink. It was either like white, black, gray, or blue, and I wanted color. So I got the blue one. Everything else is already pink. This is my bed. My bed is pink. Can you see it on... I can't... I'm not looking at OBS. Yeah, you can see my bed. My bed's pink. My blanket is a light pink. My keyboard's pink. I got plenty of pink. Sometimes you need some blue or some black to, like, even it out. I have lots of blue things. I have a blue notebook going over here. Blue folders. Blue stuff somewhere. I don't know where. No pink chair. Oh, yeah, if I could find one. I wanted this chair, and this chair didn't come in pink. So... we want if not parser consume, be kind, no output, then parser, this is probably why I don't have a parser expect. This needs to take parse results, result. Then I want to rpush results, diagnostics, Laye, error, the context, the token location, expected this, and we'll have to, for now, assert that kind is greater than 0 and kind is less than 256. Support certain non-printable lines. So then this needs to take the kind. Right, and then that means we can go back down to wherever the hell we were. We can do expect of both of these. Less than 32 is also non-printable. Yeah, but I don't have token kinds that I'm going to return that are there, because what I'm looking at is that's Laye on Laye.h. I start basically with the printable characters, and everything that's non-printable is greater than 256. So if I'm explicitly expecting a character and it's out of range, then that's a bug in the compiler, not a feature I've missed or something. So I could be more specific and pick exclusively printable characters, but I really shouldn't be passing them anyway if I'm using either character literals or the names that are bound. It's an assertion. It's not going to ruin the world. I might go change it. But I don't have like a range here. I don't think these are ordered. Yeah, that's 126. This is 63. If I had these in order, I could say like, or I could give a like Laye. What do I use down here? I do double. So I could do Laye print double character start or printable token start equal to 32. And then I can put all my printables in there. And then I could say printable character end is like, I don't know what, 128 or something, the end of ASCII for now. Then I can go back up to that assert and be slightly more. Oh, we're in full screen. That's fine. 12. Laye parse. That's the beginning of the file, you dumb bitch. Laye parser expect there. So then we can say greater than Laye start and less than or equal to Laye end. Oh. Of course, Laye print end. My aversion to typing. I'm going to do that so it's makes more sense. Anyway, so then we want the result, which we don't have yet. So we need to make a result. We can just say Laye node cast node is node create module node cast. Location would be this for now, the location of the cast node. So p token location. The type would be nothing at the moment, but I can't pass null or 0 because reasons. So we'll just do lty of p context Laye types unknown. So then we can do next token. We can say Laye parse result is result success of cast node. So I have a valid node to play with, and this is going to be results. So then we can store all of our errors into result. And the reason that we have a separate cast node here is so I can do some of my other functionality on it and set it up later. So then let's do a result cast node equals result rather node is cast node, and then we can return just the result. We don't have to do anything else. So what we want to do here is Laye parse result. Cast type result is parse type or error. If I say or error, it's going to give me straight up the type, but not the result. If I parse type, I get the result. So then, does this have a flag? It does not have a flag. So what I can do instead then is say, let's go ahead and grab Laye node. Before I do the instead, let's make it a bit more explicit what I'm doing. So we want a cast node, cast, or just type, straight up type, equals cast type result type. So then what I was gonna say we do is we just remove cast type result, and we say result with result combine, because this handles stuff for me. Results this. And what combine type does is my result can be either a node or a type. If I say combine type, it takes the type out of B and puts it into A. And since that is within a union, it will overwrite node. So what I should probably do just to be safe is a.node is null, just in case there's weird memory issues, but it shouldn't matter. But I could do the same thing here and say a.type is Laye type 0, just to make sure the memory has been properly done with, whatever the fuck that means. So then we have result combine. This will take care of copying all the diagnostics from one result to another, and then destroying the one that we're not using so we don't leak memory. So then I can say cast node type is the results type. Then we expect this into the result. Then we want to say result equals result combine. And this will switch it back to being a node because, of course, I've made a great system here, of course, of parse primary expression. Just straight up a primary expression. Then cast node, cast operand is result node. And then at this point, we've got everything. We set the result node back to the cast node and return it. Why is it not happy here? Is it literally just not catching up? Expected an expression. Yeah, it's just taking forever to catch up. So then the only thing that's missing is like cast node, cast kind, not call, cast kind is Laye cast hard, I believe is all we care about here. It's a hard cast. operator. Operator what? Assert operator to use in that exact situation. Which what situation? Let me say LCA assert. I don't have that yet. I was in the middle of potentially refactoring this. Not a good idea now. We'll do it later. No. But I was trying to combine my helper libraries over here into a single header, and in doing so, I was going to change the string representation, which would cause a lot of problems. But I added an assert here that I wanted to try to start using more, and eventually I could refactor it into a better assert than just the default assert, but I haven't done that yet. Okay, so that should give us a cast. Which operator for what situation, though? I wasn't sure what you were talking about. Okay, so let's not be in full screen mode so I can click on my stuff without alt-tabbing through everything. Instead of import, we're going to do for cast.laye, and we're just going to do syntax for now. So syntax. Non-void function does not return a value, and I'll control this. Did I give it a control? I think it's going to be this one. I made it a bool, but it should just be void. Okay, so it hits cast, and it knows how to print casts because we have implicit cast. So this is a hard cast for A to type I32. Okay, so then if I do sema, I don't think sema knows how to do this part correctly, but assertion to do cast sema. Yep. So into sema, we do cast sema. So this is for any of the cases that the compiler didn't generate itself, basically. So if it's a hard cast, we need to define some rules for hard casting. So this will turn it from a hard cast into a truncate, probably. I think I have Laye cast. We don't have explicitly a truncate in here. It's going to have to probably turn it to a truncate in IRGen. So we'll have to know the case for getting it to IRGen here, which I think is technically handled. IRGen. Okay. No. Cast. Zero extend, there's a truncate right there. Oh, it was probably case sensitive. Yeah, disable case sensitivity. So we do have a truncate here. The truncate case is if they're both ints, then it'll allow the cast. If they're the same, then it's a bit cast, which is probably not even necessary, but it's fine. Then it's a sign extend or a zero extend to go larger. To go smaller is a truncate. So we can handle this case of just, and this is for the default case, which includes hard cast. So we treat hard casts and implicit casts the same way. It's just a syntactic and semantic differentiation. They're processed the same way. So that's fine. So then we can say, if they are both integers, we'll just handle that type for that case. If, let's see, so if Laye type is int of node cast operand type, and Laye type is int node cast type, no, just straight up type, then that's fine. It's going to turn it into a truncate. They're both ints already. If it's signed or unsigned, it doesn't matter. Maybe. Because I know you have to sign and zero extend, but if you're truncating, you're just chopping the stuff off and it's fine, even if you're going from one to the other. Right? There's no instruction to go down. It's just a truncate. Right? I'm not crazy. I think we just break. And I think instead of hitting this case, we should say, we should grab the semi-convert or error text here. So we'll have to grab string stuff. I'm just going to literally copy this for right now. So from type string create, string print whatever is going to be node type. Now from is going to be node cast operand type. From type string semi-context use color. Then to will be node type. What's the examples raylib folder? It's an example raylib. Currently, it's using import, which is not implemented. But I can just copy pasta and put this in here. And I can really quickly say out Laye C examples raylib. I mean, I've already got it, but I'm going to show you that it works. Core basic window Laye. And again, for now, it's going to output the file at the exact same spot. I'm using raylib prefix because import linker failed because I need to raylib, boom, and then I can examples raylib or basic window off screen, but there it is. Raylib from Laye. All that raylib stuff. So Laye can already do this, and I was in the middle of imports, so I went ahead and refactored it to use imports and import this file. But we haven't implemented those yet. Hopefully we'll get this case done today, or at least underway, and then we can do that. So then here we want node errored, node location, expression of type whatever is not convertible to type S. So we want, in this case, that's fine, node location. From type string to type string, blah, blah, blah. Okay. So this should work. And if I remove the thing we just added, instead of assert it, I64 is not convertible to I32, but it is if it's a hard cast. So I think we should do this only if node cast kind is equal to cast hard, because we can get here through other means. So if it's a hard cast, then we do that. When do we get polymorphic modules? What the fuck? I don't even know what the fuck that is. I don't want no polymorphic module. Okay, so then that gives us an error. The hard cast makes it through Sema. Like I said, it should just turn into a truncate. But we should also be able to get IR out of it. So allocate in 64, allocate to load trunk from I64 to I32, store into 1 the value 3, that's there, then load from 3, sign extend it to 4. Hey, look, an implicit cast. I forgot about that, boys. Implicit cast to sign extend it back up to an int64. Code that changes itself. Yeah, but I don't want to do that. And return 5. Okay, so that all looks correct. We're just going to yoink it, put it right here. Up one more. And make this top one a star. Nope, that's not a star, that's a star. I think that's correct. It should return 10. So let's just knob test. Cast failed. Import failed because it failed. Cast failed. Probably because it didn't get run. I guess they're not running in order necessarily, but it looks like they are. Break continue struct east west. Import doesn't work. Cast for value kind trunk. Oh, I didn't LLVM it. Oh, I thought I already did that in LLVM, but I guess not. So cast sign extend. cast. Really? Because it's not a cast. What the heck? What have I implemented then? Unreachable return, allocate store, load, call, pointer add, built in, branch conditional, branch phi, negate, complement, add, float add, sub, f sub. Okay, so I do have some float stuff in LLVM already. That's good. So when I get through summa, it'll be fine. We can do floats sometime soon. And or XOR shift left, right, equal, not equal, less than, greater, equal. I just don't have any casts in here, do I? How? Do I not have any casts? Unimplemented instruction and print instruction. Yeah, because trunk is not in thing. Very strange. I guess all the casts that I'm actually testing right now are like L value to R value, so they turn into load. Very strange. Well, let's put a cast in here somewhere. Let's do it right after branches, let's say. We'll do here. Case Laye IR trunk. Break. I need a truncated expression now. So I used to have the LLVM instructions. I want make sure that I'm doing trunk correctly. There's all of our conversion operators. So it's just called trunk in LLVM as well. Phi value 1 to tie 2. So it needs the source type. And then it gives us tie 2. So start with the keyword trunk. Trunk. It's all in the wrong spot. The value. So LLVM print value code gen the value, which do I have operand probably? ISC operand, I think it's instruction operand. There you go. For trunk, which is the instruction. What I need to check then is in ISC H, we want ISC IR and build trunk. Build truncate is build unary, and build unary puts it in the operand. So I can grab the operand, that's the value we want, and true to include the type, then just base 2, and then the value, the type, LLVM print type, code gen, instruction type, ISC value get type, like that. Print type just takes those two, I think. Yeah. And then value get type should be fine. The unary operand type stores the type in the regular type field. So if I did that correctly, trunk whatever to I8, that makes sense. Start again. And then sign extend, yeah. So we didn't do sign extend either. Truncate, SEXT, assume it's exactly the same syntax. 0 extend 2 is the same, sign extend 2 is the same, so we'll just go ahead and do 0 extend as well. And do this. Boom. Non-test. Okay, import's the only one not working. So we've got cast for the trivial case of integers. It will sign 0 or truncate, sign 0 extend or truncate as necessary based on the existing recursion. I looked over and looked at something else. conversion rules. So let's see if I can easily do that. If it's not easy, I'm not going to do it special separate. There's changes in SEMA. The parser is unique, LLVM is unique. The cast itself is unique. So let's add test. Git add test. Let's git add. I'm going to go ahead and add everything in lib. I'll git add, git ignore for later. And I'll git add knob. And I probably want laye.h. Do I? Printable stuff, yeah. We'll leave the rest for later. Build LCA. Oh, I added LCA. Git rm cache include LCA. I forgot that was there. Then git commit add cast and prep. I didn't split those two up. Okay, so we can do more complicated cast stuff eventually. We could do it now. Don't know what else I want to do for casts. Because if we don't fully support floats in SEMA, then I mean I could go ahead and say here if they're both ints, then that's fine. So I could say bool. Well, if they're both int or they're both numeric, I don't know if I want to go to sleep or keep watching. I probably go to sleep, but I'm not gonna. Can't tell you what to do. So either. I should probably add an is numeric so I don't have to check for is int or is float all the time. Because they'll cast to each other. Is numeric Laye type is int or type node kind is equal to node type float. That gives me both of my nodes. So then I just gotta go below float in here, do that. So then in SEMA, I can replace this with numeric. And then we can cast to and from float or integer, and that's slightly more useful. I thought it was so much closer. All I wanted to do is non-cast. Why do I always do that? This should still work for cast. Yep. No change, basically. So git s, git add lib laye, star, git add, include laye h, git s, git. Okay, that's good. Git commit laye, allow numeric casts instead of just integer casts. Cool. That gives us a cast test. Now, let's see how we feel about imports. How do we feel about imports? It's resolving top-level types, analyze node, analyzing type, building struct types, analyzing modules. Right. So here is the thing. This, we parse a module, we get a module back. When we get the module, we push it into source modules. Source modules is just a fuck ton of modules. We then operate on all of the modules from the input files. So I guess what this means is if the input doesn't contain whatever we imported, we don't show it in debug output unless we modify this to allow that. Then IRGen doesn't work for any imported module because we're only going for input files. And the reason we're going through input files is consistency. We should probably not be doing that, honestly. We probably don't want this source modules thing here either. we probably want to move this into the context. We probably want to do the same thing for IR modules here. The LLVM modules can stay outside because they're a back-end thing. And we're assuming that you're generating LLVM right now. So that'll have to move somewhere else, but not here. Or not into the context. So in laye.c.h, we have our big-ass context. All of our strings. We probably want Laye modules and IR modules, and they're all going to be null by default, but that's just by allocation. Good night. Thank for join. Laye modules, IR. So then we want this to be gone. We want, whenever we handle parsing a module, I think that's where we want to put context. All good, sorry I streamed so late. Straight in there. Like that. So then, when we're going through everything here, it would be through context, Laye modules. Then we grab that out of here, and then we do the same thing here for context, Laye module. This will do IR generation and push it into context IR modules. Like that. And honestly, doing IR gen like this should probably be the thing that pushes, which means we'll probably want to move it for that as well. Maybe not. When we generate a module here, I'm going to say module context IR modules. Like that. So that's where IR modules go. So then for each context IR module, then when we're printing, that's doing validation. Printing module information, Laye module, IR module, print. Interesting. Wait a second. I think that was just a copy pasta error from forever ago. If we report errors, we just stop. And then we print things here. So this is where we want context IR modules. Then here we're generating LLVM. Like that. Then we're back into LLVM. So then down here, we don't free either of these, but we do copy this into context destroy. Move this one over here so I can see it. We want to go through a bunch of things and just destroy a bunch of them. I'll just put them right here. So for context IR modules, and then context Laye modules. What the heck? Then, I mean, this should probably go up here with strings. So Laye modules and IR modules. Then knob run. Actually, if I look for not knob run, I look for, what was I doing? Import. Okay, lots of things it doesn't like. Let me do clear and then work on wall. It really doesn't like. Laye module, did you mean Laye C module? Oh. Laye C.h. Struct Laye module, and probably the same thing for Laye C. Well, that's up here somewhere. Question mark right there. That's fine. So then by the time we hit here, we include Laye, so that should be fine. Okay, so then we're just searching through things again. So knob test, no breaks, compiler still works, cool. Beautiful. We did that to give us better access to whatever is going on. So Sema. Doing Sema to thing. Doing IRGen here. We're doing syntax up here. Analyze. Modules. I mean, this should happen right away. And honestly, I think like we did before, as soon as we create the module in the first place, push it into context. So we don't have to track it externally. So then, here, the only reason we're doing this is to, I don't know why. That's for fcheck. Water. This first. Then water. Water good. So parse module. If it's reported errors, do a thing. Print AST. So then we just do the exact same thing for print AST. So basically, let's try to factor out Sema because I think that'll be useful. Here. Why can't I understand where things are? Let's start with back in parse module. Don't even handle semantic analysis. Start there. So here we literally just parse. Sleeping is difficult. You've been gone 10 minutes at most. If it has errors, if we print AST, we do the thing. If it's syntax only, go to program exit. Right. So then do it again, but this time for every module. Here is, I'm not going to say the problem, but a problem. If Sema introduces more modules, then this will, I mean, it's fine, I guess, if we're recalculating the length every time. And if we mark a module as in progress, it will stop. Kahuta, oh, yeah, screen. Good call. So, how do I want to enumerate this, basically? I could do a queue of things that need to be done that I keep iterating through, but I don't know if I need to go that fancy. What do I need to do? Just figuring out the correct way to do this module import is going to take a sec. You know how to work? What? No. I want to go with no. I don't do Bluetooth if that's what we're talking about. I think that's just a typo. Um, hmm. Make a copy, but the underlying memory could. No, that'd be fine. I mean, if it doesn't reallocate, it'll change anyway. Basically, first, don't need this anymore. Module is context, Laye module, sub I, a search module, not equal to null, because at this point it should not be, and Laye analyze module. Then this is for IRGen. Then we can copy this. So this is identical behavior, which is fine, which is good. That's exactly what we want. So let's make sure I didn't break anything with my identical behavior refactor. I don't think I did. Return diags no exec Laye failed. Interesting. Not identical behavior. So return diags should be specifying this. I think what I'm missing is this. Maybe. Probably not going to change anything. Yeah. So if print AST and syntax all meet first, still don't think that's going to change anything because we're not modifying the exit code here. But apparently it did. Apparently that works. Okay, so now we're doing analysis. Do I want analysis to operate or to be handled at the module level like this? Or do I want to have an entry point that can go through all modules? I think I do. Let's do Laye analyze context like this. So then we need to go to the declaration and we want to analyze all of the modules in a context. Right? Then this changes significantly. The signature must be correct. Context should not be null. Laye dependencies is a dependency graph. That's fine. Then we have Sema operating on a context with both of those things. Let's do static void Laye analyze module, Laye module. This is where I can grab something like module and context. Then we don't need to push to reference modules anywhere. We're going to traverse all of our imports, handle doing more parsing on imports, whatever. Generating dependencies for every module. And then once we are done generating dependencies, we have all of the ordered nodes that we need to process. So at that point, we do Sema on those nodes. We do Sema on those nodes. We don't free anything here. If we're doing ordered nodes, then we don't even need this analyze module. right? So traversing all imported modules. Step 1 is going to be for int64ti equals 0. Count is array count of. See, again, if we're modifying the array that we're iterating through, I just need to make sure it's not. We should only ever be appending to it. So if I pre-declare count, but then we want to make this recursive, so it probably should be recursive, and then we iterate over everything. So if we do a function to populate, so yeah, if we're doing it recursively, then this is what we want. Context Laye modules. I is less than count I plus plus. So then instead of having a analyze module, we want to traverse the imports. So static void Laye handle module imports, Laye module, assert module not equal to null, context not equal to null. I can spell context. So this is where we want to iterate all of the module's top level nodes. If it's an import, then we have to handle importing the module. This is where we would add it to the context, I think, and then call handle module imports on it. I also think that this is where we start setting module. Do I have a semi-state? I don't. We're going to create a module semi-state. Dependencies generated is an interesting flag. So my semi-states include not analyzed, which is the default. In progress is for it started. Errored as it's failed, okay as it's not failed. Do I then want things like, but it's a Laye C semi-state, not a Laye semi-state. I could just make a new, I could use flags, I could make a new module processing state in Laye.h. So let me use my actual windows here. Now that they're kind of tiny, I don't want to anymore, but. So in my module, which is somewhere here, semi-state, instead of doing semi-state, and instead of having this dependencies generated, which is here, generate dependencies for module. If it's done that, then we... So I think for right now, keep it simple. We'll change it later. Bool has handled imports, and we'll just throw that at the top of our other function, which is nearby this. If has handled imports, return. So we don't walk the import tree for any given module more than once. So the next thing we've got is this source ID is basically our module identifier. So when we handle import, we need to be able to get a source ID for the import string here. And then we can use that to look up if this file has been read already. If it hasn't, we make a new module. If it has, we skip it. So let's grab the name. We don't care about the alias right now. We want the name, which must be a file name if it's a string. If it's not a string, we're not going to handle it yet. We don't support non-string just yet. We might, but not right now. So top level node, import module name should be a string view. That's a token. Laye token name token module name token. If module name token kind is equal to token identifier, I could assert false, but I'm going to just write error. For module context, module name token kind. Currently, module names cannot be identifiers. The syntax is reserved for future features that are not implemented yet. Just to give me a good idea of where I stand, string view module name equals module name token string value, which should be a view. It should take this. It likes this, right? Good. Not kind, location. Typing my own name instead. Okay, so now we have the name. We need to build a path out of this. So, do I have... I did in a different version of a compiler. I don't think this one ever got it. String concat. I had like a path concat that handled path separators for us. So I probably want to go reintroduce a path concat. So it was like in string builder or something. I don't have a string builder anymore. So we also need to know if a file exists. I don't like having to open a file and then close it, but I probably have to do that. Unless I write a wrapper around platform calls, like fstat. So long as I put it into a function, I can worry about optimizing that function later. Let's go into, because we're like, check file exists. If I do this, it's going to say use fopen and then fclose, right? Access unistandard, so it's going to be a POSIX thing. Under VC, does not exist. Okay. I want read permissions. Weird. So I might just want to implement this in terms of stat and something else on Windows. Open. Yeah, so on Linux we can use stat. On Windows I don't want to figure it out right now, so we'll just use fopen with read. So let's open LCA plat and check bool LCA plat file exists. It's not void. We want file path. So then here, I could do this trick, right, with access that we were just looking at. But if we say if def Linux and if, then return something about fstat. All right, I'm on Linux. I can use man stat. Does that give me what I want? Display file or file system. Okay. But this is a thing. That's stat 1. If I man stat, what is... I don't actually know how to use man. It's what, that 2. What's that? That doesn't do anything. How do I do stat 2? Man 2 stat. Okay. Man 2 stat. That gives me this. That's good. So then this path name stat buff. And then fstat if you have the file descriptor already. So we want It needs to be include sysstat. So then we can say struct stat buff, was it? Stat, destruct stat. Okay, struct stat, stat. Be good about my initialization. And then we have int. What is the return code? Interesting, okay. Return value 0 is returned. Okay. Int error equals stat. Oh, I can't call it stat though, because stat is a function. Stat info. Stat file path ref to stat info. If error does not equal to 0, then we have error no information. So we can just. I don't have elegant error handling here. If I just printf standard error, do you get error no to string p error? Is it p error? Not p error, p error. Prints a descriptive error message to standard error. Okay, so I can just call p error. And this takes a string, which I assume is just a format, the C-string custom message before the error message itself. So like failed to stat file. And it doesn't take a format, so unless I do my own format, it's just going to say error. Interesting that they included the colon even though they had the output here, but okay. So is there like a p error f? Probably not. No. Okay. But that's good enough. Because it's very rarely going to happen, I imagine. And if it does, figure it out later. Okay, so then we want to return stat. So it fails if it doesn't exist, which I guess actually is an error case we would want to handle. And instead of p erroring on something, we can check the status code. Search permission is denied for one of the directories. So we want enoint. If error is equal to enoint, return false. Otherwise, stat the error and return false anyway. So then here, what does stat contain? Stat 3 type. So if I did man 3 type stat, is that what that's saying? Yeah. So I could just return true and worry about readability later. So if I just return true, we can worry about actually stat infoing separately. Else file f equals f open file path for read f close f. If f is equal to null, return false. Otherwise, f close return true. And I can worry about implementing more platform specific stuff later. I think that would work. I'll leave that open, find out soon. So LCA plat file exists. We need a buffer man2 string. Okay, so string. Oh, my arms feel ugh. Look up path will be string create with an allocator, which will just be the default allocator. Const car lookup path. I mean, I can just say string to C string, it's string view, string as C string, lookup. So we have a bunch of different places to look things up for. I can simply iterate through them and do this on my own. Let's just start with string end format lookup path mod s, and it's mod.star s, and it's a string view. Stir expand module name, and this will just be our thing. So we can say if, and we're not including library or import directories yet, so we'll worry about that later. If not exists, then we report an error at the location of the module name, saying that it can't find the module to import. Otherwise, we continue. So this will, I mean, we'll continue regardless, or just continue. Right? Two different kinds of continue. Write error for module context, module name, token, location, and cannot find module file to import. Mod.star s and str expand of module name token string. Well, we have module name right there, right? Then we should have the ability to ISE source ID. Source ID is ISE source from file module context file path. The file path is a string view. So we can do string as view. String as view lookup path. Now here's a question I have. It just takes the name verbatim without interning it. So the name of a source really should be a string view. So should the text. Both of these should be string views. I was bad about not using string views. So this needs to be ISE intern string view, string as view name. And this needs to be, we don't need to intern this string necessarily, we just need string as view. Because this one shouldn't change. Oh, context. But here's the thing. I think the reason source used them as strings is because specifically it was owning them. So actually, let me go back, and for now, I don't want to break everything. We're going to leave it alone. Since it owns them, that also means it's going to free them for me. So we'll go back to making them strings. I was going to say that this is a problem because I have to free the name, but see, it takes a string view file path. And then it does become something that it can own. Okay. String view to string. So it does, okay, so no, it does own that. Okay. So lookup path, string destroy, lookup. Let's do that before I forget about it. Ownership, woo. So then we have the source ID. Then we want to look up. It has to be a reference to look up path. Like that. If the module exists and we have not yet handled imports, I'm going to just do handled imports at the top instead of the bottom to early out. This is in the process of happening, and there's no third state for a bool, so it should just happen. So then we don't have a lookup based on a criteria because we don't have closures or anything. And I don't want to generate that kind of code with a macro. So we're going to have to, for int64ti equals 0, count equals r count, module context, Laye modules. I is less than count I plus plus. If, so bool found, or like int index maybe. If we found it, then it should stop, but it needs to add the reference. So we do want Laye module found. So for as long as I is less than count and found is equal to null, if this module here, Laye module equals this sub I, if module source ID is equal to source ID, then found is module. If module is equal to null, or if it's not equal to null, let's just continue. Already loaded, should be doing things. Right? If not, we need to parse the module, and doing a parse will put it into the context here. So then instead of doing reference modules, this is context modules. Then we can generate this dependencies. Module doesn't exist here, so that's fine. That's circular, that's fine. Okay. So traverse all imported modules. This is fine. Let me go ahead and make this call so we can start running tests on it eventually. Context, Laye modules, sub I. This will handle all of the pre-existing modules because it's going to stop at the original count and we're only appending to it. And I should probably just pass the context along with it. I don't have to keep indexing through Laye. Laye C context, context. So that. So everywhere that we use module context here, it'll just be context now. I should have really done that in the first place, but okay. So that's fine. Now we need to parse a module. To do that, we can grab the Laye parse function is actually all we need, so I don't have to grab anything fancy. Laye parse context source ID. Assert the module is not equal to null. It's been appended to the end of the module list. Now that it's been appended to the end of the module list, we recursively call handle module imports on it. Context module. And that should generate, I don't know why my eyes. Ugh. Now we should be recursively handling module imports and stopping at modules that have already been handled. So traverse all imported modules. Generate dependencies for all of the modules that now exist. Generating dependencies for modules is doing nothing at the moment except for ensuring that they're tracked. So ensuring that they're tracked means this is something that we want to do further semma on that also could be part of a dependency graph. Import nodes don't need to be tracked in the dependency graph because they only create dependencies between modules, and we want to allow circular module dependencies. And we don't have to do any semma on them. The only semma needed is importing the file as a module, which has already been done. We don't track an import. We do want to track these two declarations. We don't have anything top level yet. We're not doing globals just yet, even though they're like half supported technically through the IR backend. They're not in semma yet. So does this not break? Ent doesn't exist, but otherwise. Yeah. So ent, it doesn't like. My man ent, or is that not him? Man stat told me to man to stat told me to include sys stat to get stat. AT constants are there. Is what? Where are these at? Where does ent come from? If I just try to go to ent, it's in Arano base. That doesn't help me because where do we get? Is it standard error? Is it error? Arano, yeah. Okay. Now is Arano standard C, GNU C library? Yeah. We'll include Arano. We'll try this again. That looks to have worked. Cannot find module. That works so far. Import depslibc. Hey, it tried. That's interesting. Failed to stat file, no such file or directory. Yep. Okay. So that's because we haven't done the relative pathing of the parent part of the file here. So we really should take every part of this file except for the file name and then append this to it, this part. That will give us the relative location. So that's why I wanted path stuff. But it's at least trying now. And the fact that it's even getting this is what's interesting to me. This test was not discovered by fcheck before. Or if it was, if it was, it wasn't doing something. I'm going to leave it as is for now. So I really don't... Well, okay, actually, wait, hold on. It's saying no such file or directory. Failed to stat file. Didn't we tell it not to do that? If it was ent? Or is it error no? That's what we want. If I do that, do we not get failed to stat file? Okay, that's what we wanted. Okay, so that's better. Now. Thinking and braining and braining and thinking. We need a couple more string methods, functions, to append path stuff. So what kind of API do we want? First off, yeah, I think I got that backwards. Laye H. I think it's expression has no type. Like that. How about that? That fix it for you, Mr. Mugame. Discord link in the description, by the way. Good sleep music. Music. No. Podcasts, yes. I had some really good sleep music that I liked. It was less music and more just like gentle ambient chords with some sound effects thrown in. And then it got taken off of Spotify for some reason. So I tried to recreate it and it wasn't as good. And I don't remember where I put it. Maybe I do music on stream one time and we can look at making a go to sleep music. Maybe I do that. I've got to buy a license to my DAW to use it again. It's in demo mode now, but okay. So LCA stir.h. We want some new API here. Let me split this up so that I can more easily tell what things are. So we want some things. Let's make we don't want like a dedicated path type, I don't think. It's kind of annoying. So if we did need more water, need brain to work. Brain need water. Path append. A path string. We'll call it just straight up path. Then we want, in this case, to append. Roommate's playing a lot of video game. We want the default one to append another string. We want to be able to append a C string, probably, and append a view. Goddamn. LCA string view. Like that. So those are the three we definitely want. The one we want now, right away, is this one. LCA string path append view, because we have a view. So let's come over here, define string path append view. That's going to be PS, LCA string path append view, PS, like that. Format. Then we can go implement this right above view from C string. Yes, that's fine. So we want to say stuff. Insert path not equal to null, like that. Then we need to know if we need to insert a slash or not. And for now, we're going to assume that it's always going to be a forward slash with no backslashes, because Windows should accept that no problem. I don't have a constant for it, and I don't want to add one. So, bool path ends with slash equals path dot not equal to 0 and path data subpath not -1 is equal to a slash. And then just in case somebody has provided one, backslash. Right, and I believe LCA string has a count no problem. Count, yes. Here. So then bool view ends with slash equals s count is greater than 0 and s data sub 0 is equal to slash, or s data sub 0 is equal to a backslash. If both, we want to offset the view by 1. If path ends with slash and view ends, or it shouldn't be ends, it should be starts. Where's my first off? This. Second off, view starts with slash. Then s data plus plus s count minus minus, view starts with slash plus. Okay. So then, if not path ends with slash, I guess because we're in a block that doesn't exist, it doesn't like IntelliSense. If not path ends with slash, LCA string end format is just the easiest way to do that. Path slash. Then really, I could just do both. Mod.star_s, if it does end with a slash, we want mod.star_s. If it doesn't, we include the slash. And in both cases, stir expand of s. Should be that simple. This also means that if the string is empty, it will do this, which is probably fine for now. I don't know if it's actually fine. Okay, so the next thing to check is we need like string view index of. Interesting, we have extension stuff, that's fine. With extension, we don't have index of. But yes, we just manually calculate the index of things here. We want string view last index of S and C like this, and regular index of like that, which we can define up here as int64t LCA string view index of string view and C the last index of. And for both of these, we can go above, change extension. And we can just use this for last slash index. So C, then return time. Okay. Right. That'll be x count like that. Okay, so then regular index of is kind of the fucking opposite. So I equals 0 less than count plus, don't need both cases, there's only one case. Cool. That looks good. We won't worry about implementing this yet because we're doing dot. I can do it for dot, but I don't care. So index of and last index of. We want to get the part of the string of the source file that does not include the file name, which will basically be this thing. We want this. And important to know, fcheck is doing this. We are not. But that's fine, because if we do ... that should get resolved anyway. So let's say we want string view this file dir path. Let's call it dir, that's fine. So this will be the module's file name. So else habitaba. When we get the source, context get source. ISD source equals this context module source ID, right? Then we can say source name, which is the file path. If it's a file, I don't have a flag indicating whether or not a source comes from a file, so we will probably want to skip this on. We'll probably want to skip this on sources that don't have backing files on the file system, and just do like include directories. But ISC source get name is what I want. I don't have that, but it's just .name. So source, oh, because it's a string as view. I was wondering why there was an error, because it's the wrong type. String as view, this whatever. So then int64t, let me do it this way so I know that it's grouped. This file dir int64 last slash index equals string view index of this file dir slash if last slash really we want the max of this and the backslash. Max, which doesn't really exist, right? It's capital max? No. So I don't really want to recalculate it every time either. So I can do last index of 2 and ask for 2 things. Or I can do an imax, max I function. Yeah, let's just do LCA max I. Between this and this. Give myself a nice fancy, I don't know where I'm gonna fucking put this, max I. We're gonna put it right here. Static void 614 max I and 64T A, 64T B. And we can just put it in B. Edits. We did it. Yay. If last slash index is equal to 0, -1 is less than 0, then let's get the lookup path and say if it's less than 0, append format just dot. Else append format of this file dir append format doesn't have the fancy mechanism to not take VARGs right now. So this one though will have args. It will be mod.start s we will want to get this filedir count equal to last slash index, probably minus one, and then stir expand this filedir. Then, instead of append format, we want to path append view this. Then, just for shits and giggles, fprint expand lookup path to just see it. Yeah, I have one nearby. This one. Oh. Is a pointer. That's 204 and something else. I'll see a stir 38. This is LCA string and LCA string review. Okay, 204. Everywhere that I use path dot here should be path arrow. That. Okay. Could not find file to import deps standard IO. It's also not printing. I think it was printing, yeah. Test, the -1 is wrong. That's why. I thought, oh, that's probably fine. No, apparently not. There it is. So it found test Laye depth standard IO, which is good. Keep that around. So then it should have imported that. So now it needs to do lookup through imports. If all worked, we have this. So the one thing we need to do now is reference the module that we imported. So top level node import decal dot reference module is module. We now have that. I don't know where to put that yet. Don't know where to put that yet. More water. Good water. So now we need to figure out how to actually look up these imports. We have them stored here, right here. But when we do generate dependencies for module, it's not going to do anything yet. We are not traversing imports just yet at the top level. We will eventually when we want to do like referencing struct types in other modules. But we need probably to either pre-process all of our imports into a pre-process all of our imports into a special case lookup table that pre-handles all of our queries is probably what we want to do while we're handling imports. Then when we generate dependencies, we can eventually just traverse those no problem. And the same thing for actually analyzing child nodes. So what kind of structure do we need for that? What kind of structure do we need for that? We're going to put it in Sema, probably. Go up to Sema. whatever we do, it'll go here. Type def struct something. Laye sema import info node namespace scope reference import. Start with that. It's going to reference the import itself. So Laye module imported module or referenced module to be consistent with the declaration. The module that we're importing there. Then we want probably just an array of key value pairs for every name to node. So to get the key value pairs, type def struct Laye sema import AV, we'll just call it. This will be a string view name and a Laye node entity node, something like that. So then I can just make an array, because we don't have a hash map yet, of this for imports, right? Then this definitely works, no problem, for these kinds of imports. It doesn't work, no, rather it works for these kinds of imports because they'll have a name. So string view name, either libc2 or libc in a namespace. When we're generating no namespace, this should probably be empty, and we'll have to include this in the search at any given point in a module. And this shouldn't be a sema thing. This should be in laye.h itself, because we want to store it in the module. So instead of sema import, we'll do a module import and a module import kv. Put these up here in right above a module. There's a scope, that's fine. There's a module. So then there's our top level node. Laye module import. Resolve all of our imports to this array here, which turns them into a name, a referenced module, and a list of actual imported values. Call it entities. Or instead of queries is what I called it here, but when we're done resolving a query once we point it to an entity. So entities has a name and a node. So an import entity like that, list of entities. So then when we're doing name resolution, we check all of the existing declarations in the scope, and then all of the imports that don't have names, question mark, or do every time it doesn't have a name, we just add it to the scope directly, the module scope. The module doesn't store its scope, so I can't actually access it here. So we should probably say struct Laye scope, which should exist actually. We have all scopes, but we don't have the module scope. The scope is done in the parser. So module scope, module scope, module scope, like that. We have the scope, all the scopes. We have a new thing for imports, which will need to happen in module destroy. We'll have to get rid of imports like that. Okay, that's good. Don't need that. Don't need that. So then we traverse only. Okay, so yeah, we're not going to add something here unless it has a namespace. Otherwise, it's going to go directly into the scope. So back in Sema, back in wherever the hell we're handling import. Here. We've done this for completeness, but now we want to generate an import. If and only if it has a namespace. And otherwise, we need to populate them in scope. So we want to be able to resolve all of our queries if there are any. So let's say first, if it has an explicit namespace, or it doesn't have a namespace at all, and it doesn't have queries, then we do the case of generating a namespace, which is going to go in the import tab, the array here. So if the imports are empty, that's it basically. If top level node import decal queries is equal to 0, then generate an import otherwise for everything in the query, populate the module's scope with the imported. And in this case, we want some function to resolve a query, so I don't have to do that in line here, probably. To resolve a query, we need the module it's querying from, the query itself. So we can probably turn that into an array, because resolving the wildcard query, while technically trivial, it's part of the query list. It's an error, so we shouldn't get here, really. So we could, let's just put it into a function so it's a little bit less stupid. A dynamic array of declaration entities. This should actually probably just return this array here, so we can populate it directly from here. Module import a list of entities. That list of entities is going to be necessary here either way, which is probably why we should do it like this. And if that's the case, well, no, because we've already branched on the two different cases. If it is whatever, it will fit, has no queries at all, then we put everything into a namespace. And that namespace is that list of imported entities. And the only thing we've done to make that useful, we don't even need this. That's what's confusing me. This is just Laye node. Straight up. That's all I need. Because it can only import declarations. And the declarations already have a name here. So I don't need this. Here, I do still need to gather this. but I don't need to construct anything fancy. So we can call this just entities equals Laye sema resolve import queries. In context for this module, with arms don't know what to do when I'm thinking. God damn it. Resolving the import queries, context module, and then we just need a list of queries, which is up level node import decal queries. Right. Then for each of those things that we've resolved, we append them to the scope. We can then also assert that array count of entities does not equal to 0 unless it fails to look something up, in which case it's going to write an error and fail. So it's entirely possible that there are 0, because we probably don't want to append non-existent nodes to the scope. So that's actually fine. So resolve import queries. Static dynamic array, what? Of Laye node, this, from context and module, and a dynamic array of import queries, like that. Do are ye olden, not that, like that. Then dynamic array Laye node entities is null. Now, here's the problem. I'm actually going to move this below here. No, I think that's fine. I was gonna say, no, just in case. I have absolutely no idea if this is necessary, but this whole thing here, I'm going to put into a separate function. And that separate function is going to be, basically, I'm just going to copy this and remove all of the stuff that's actually doing the import. And just do this. And this will be populate module import scopes, like that. Right. So then we can just do this, and then for each, now we have an entirely new, complete, hopefully, list of modules. So then, as another step, Laye populate scopes for this module, which will go through all of its imports, resolve all of its queries, and then we're good. Then, once all the queries have been resolved, we're able to traverse the import structure, so we can generate dependencies and do sema. The only reason I'm doing this separately is just to avoid, as much as possible, the circular dependency problem that we want to not be a problem. Circular dependencies should be allowed. So, at this point, we've recursively done everything. We have all of the modules imported, ready for sema to be done on. So then, populate module import scopes is where we're at. Let's assume that we've got everything. In this case, for int64t on equals 0 is array count of entities. As less than count by plus plus. Ye old usual. Laye node entity equals entities sub I. Assert Laye node is decal entity. Assert that entity declared name count is greater than 0. And just for shits and giggles, that its data is non-null. That's what we're dealing with. So then, scope declare. Laye scope declare. Module scope entity. That should do everything I want for this case. Literally import it into the module scope. And here's the thing. Okay, Sarade, if you're here, here's the thing. This might want to be a proxy if we care about marking the linkage of the node. And I don't think we care. But, no, I don't think we care, because we're not iterating over the scope when we're printing anything or generating IR. We are iterating over the top-level nodes, which this is not affecting. So I don't have to say this is an imported entity, because while it's imported from somewhere, it's never going to exist in this state in a manner from which it needs to be imported. Words. So it shouldn't, okay, this should be fine. When I'm doing IR gen, that's going to be a problem. I don't know if it was a question so much as a statement for you to validate. I think this doesn't matter in SEMA, it'll matter in IR gen. Because what we're doing here is we're importing an entity from another module into this module scope. But as far as SEMA and the IR are concerned, or at least as far as the IR is concerned, which is the important part, this entity doesn't exist within this module because it's not part of the top-level declarations of the module. It's just in scope. So what I will have to do, maybe, is generate the correct forward declarations, which is maybe where I'd want, like, to make my life easy, maybe I generate a proxy top-level declaration with a new linkage. The question is about linkage, sorry, basically. Right, so if I'm, let's go to the raylib example, because that's easy. Raylib.laye. These are imported from raylib. These will have the re-exported linkage, because they are declarations that are being exported. So they're imported, but then exported, so they're re-exported. These are re-exported. If I go to core basic window, and we're importing this thing, these declarations don't exist in this module, but they need to, at the IR level, be able to reference these symbols. So these syntax nodes don't need, technically, to have their linkage fucked with. I don't think. But to ease generating IR, that generates the equivalent imported declarations here, so that it can reference something valid. Maybe I create a proxy node here that changes this from re-exported to imported and attach it to the bottom here or something. I don't know. So less an actual question and more is what I'm saying making sense before I go try to do it. Because IRGen is traversing the syntax tree, not the semantic scope, and we're adding entities to scope. So if I just IRGen this without doing anything new, all of these function calls will point to data that doesn't exist in that IR module. You know, if I'm treating these, each Laye file is basically an O file that needs to be linked, because I'm generating separate IR modules for each Laye module. And then each of those is a separate LLVM IR module. Yeah, so I'll have to import declarations, which is why I'm thinking maybe I just, when I insert something here, also generate a proxy declaration. So I don't have to do a retraversal. I'm already doing the traversal here. So if I, for example, let's go up to my node kinds. So here we have all of our declarations. If I just fucking decal proxy, like import proxy. And the only purpose of an import proxy is to contain a reference to the actual declaration node so that IRGen doesn't have to look it up again. That might be okay. So then I could say Laye node proxy entity is node create. In the module node proxy location at entity location. I don't think it's going to matter that much. I just don't want to duplicate the traversal because it is recursive in nature. Well, I guess I'm going to have to retraverse the namespaced imports anyway. So here's what else I'm looking at then, is I have this list of imports. This is what Sema is using to traverse path expressions, right? Looking up paths. Then if I do this proxy strategy, rather than appending it to the top level nodes, which I could still do, I guess, that's not as important. What I would... Because then I'm thinking, well, no, I can associate it with the proxy. In IRGen, I associate the values of things with their nodes. Nodes contain the IR values they declare. But I can just walk through the proxy to do that. The proxy would never declare a node. Oh, but it would declare a node. So then Sema should reference the proxy. Now I think I do need a proxy, but I don't want a proxy. Because unless I do a hash map. Because now the problem is, if every declaration contains its IR node, which it currently does, then when we resolve a reference and point the name to the node, it's always going to reference an IR value that's in a separate module if it's from a different module. So the solution to that is to use a dictionary or a lookup of some kind to go from node to IR value without directly storing it, so I can have a one-to-many, one for each module. Yeah, that's basically what I'm doing here. Yeah. Yeah, I have no idea, Mr. Mugame. That's a problem I'm having as well. It's like it looks exactly the same for me. This stupid thing, and I mentioned it one of the last streams that it was stupid and I hate it. Because yeah, the last half of a word just doesn't show up. And there's no way to do anything about that. Maybe if you pop the chat out, Maybe if this gets changed to live, it probably should be live chat. If I do live chat, it gives me this welcome to live chat. And then it's not a problem, but it also breaks. Not because then it puts stuff underneath it. That doesn't work either. Chat popped out doesn't work either. Okay, so it's the same thing. Yeah, it's stupid. Anyway. So, anyway, IRGen is probably going to have to change so that the nodes that I reference, so that I don't need proxies. I was going to use the proxies for something, but it's not worth doing. So we just need to keep a list of everything that we've imported, which we're doing. So we don't need a proxy. We might need a proxy in the future, but we don't need it right now. We will have to change IRGen when we get there. This is what and this is exactly what I said here. Makes it easier to keep track of, since we don't have to use hash tables. But if any given node can have multiple IR values depending on, one for each module that it's present in, then I can't do this. So, what the heck? No data. Oh, connection back. Stream may have dropped for a second there. It told me no data. But now it says excellent connection. If stream's been dropping, that's annoying. But it looks fine now. I'd create a browser extension, but some don't want to keep up with the JSW, the Google Pay, change. Yeah. That's wild. I've never looked at how YouTube extensions work, but if somebody is actually changing the class names, that's annoying. Yeah, that's stupid. Okay. If I remove this, how many places in IRGen are fucked? Only a handful. Yeah, this is where I would want a hash map, which I don't have yet. I could write a hash map. I could give in and bring in STBDS for hash maps. That's probably what I'll do, is use STBDS for hash maps. I'm using my own dynamic array, which is why I haven't used STBDS. But it's probably time. Battery at 13%, that's not good. We don't like our battery being at 13%. Okay, so let's, for the time being, keep the IR value. We'll worry about IRGen when we get to IRGen. But big ol' fucking to-do, need to use hash maps to store IR values for nodes, since we're using the exact same node for imports as exists in TLDR. TLDR, IN node and value must go. IN module or So currently, IRGen just operates through a builder. You don't have any place to store the nodes. There's no IRGen context. So I could start passing around an IRGen context. Or I could put it in the module. But generate node doesn't even take the module in. It'll get the module through node, but that just feels weird. So I should probably create an IRGen context here. So we'll say IRGen. We'll do that. So we'll worry about it later, basically. But that's the thoughts all figured out. Water good. MSVC is truly something. What do we got? Doesn't consider atomic to be a keyword. What? 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 That's true. Yeah, I've been using regular ass arrays. Probably a lot of code in there to deal with jank like that. I've just been using arrays with lookups, but eventually they'll want to be hash maps, but I'll probably just do arrays. Okay, so this should still fail. I haven't done a knob test in a second, so let me make sure. He didn't finish doing something, apparently. Laye module must use struct or tag to refer to Laye module. Referenced module. Oh, because it doesn't exist yet. Didn't forward declare that? Way the hell up here. Type def struct Laye module. Did not get type def up here. I could just say struct Laye module pointer. That'll fix that. Then we don't have semi-resolve import queries because I put it back at the bottom instead of leaving it up top. Right here. Then Laye node import query. Struct Laye import query shouldn't exist anymore. What? Import queries is up there, that's right. So then this is interesting. What did I do for imports? And it's the alias, the pieces, and a wildcard. So that's this. Nobody uses it anymore. I guess it's because I made wildcard an import query, so I just moved it into here as a node, which I mentioned in Discord at one point. So this should be Laye node import queries. But here's the thing. This is this module that we're importing from. This should be the referenced module. We're querying into that module, which is wrong. We're not, because this. So really, we want decal import dot reference module that module is not the current module, but the module we are querying into. That does that. Now, knob test doesn't have compiler errors, it looks like. Nothing else is broken, except for import still fails, of course. And it's going to terminate with module is not equal to null in 262. If I run this, same thing, 262. That's here. Ooh. Ooh. Top level node, echo import, module, make them up. Which is gonna fail, we know it's gonna fail. 277. Why? We're not reporting any errors. Oh. This. Okay, we're back to doing lookup. That's good. That's what we missed. So now we don't have lookup. There's nothing to look up still because we haven't done the querying to do the lookup. Oh. It's almost 8 o'clock. When did I start this? 5:15? 2.5 hours? I can't say I didn't expect it to take forever to do imports. I'd consider this more than halfway done. We've probably only got an hour or two left, but I'm starting to run out of steam. Do I want to try to do import queries? I think the import query can share code with the value lookup system, but it's not currently designed to support that. And it's biased. Oh. So this is a problem. I might need to change my declaration namespacing, which will simplify things. Mostly. Currently, there are two different namespaces in a scope. There are the value and type declarations. Value being not a type and type being a type. So like functions and function declarations, global variable declarations, all that shit goes here. Structs, enums, aliases, those all go here. But well, this is a similar problem to overloads, isn't it? So importing the name printf should probably import every single entity with the name printf. So I don't actually think this is a problem. Because if the name printf is ambiguous, we just grab everything. And that contributes to overload resolution for functions as well. So I think that's fine. Right? I think that's fine. I think that's fine. I don't think I have to change anything. Yeah. Okay. So then, what I was basically saying is somewhere up here, we have lookup type declaration, we have lookup value declaration, which take a name ref. They are largely identical, save for the word type and value, and the fact that they search for things in different namespaces, right? So lookup value versus lookup type. If I can factor these out into the same function, scope lookup value and scope lookup type also just look up from. So I could type def the type of this function and pass in the scope that we're looking through. And then these would become the same thing. So I say this, but I guess if this returns an overload set, we just unpack the overload set. Because when we're doing a regular lookup, we want to know if it's an overload or not. But if we're just importing names, we want them to become overloads as well. So we unpack all of our overloads and let the lookup regenerate overloads, which is fine. So that's that. Then down here, yeah, I think I'm going to call it for stream here. I'm running out of brain power. I might get this done off stream. I might stream tomorrow to get it finished. I don't know. As soon as imports are running and tested and working, I want to switch back to Hibiku. So depending on timeline, we might get Hibiku streams this weekend. We've got to refactor a couple of things. I named the allocator wrong. That's an oopsie I got to fix. We got to get the parser underway. I've got to start writing some more docs for it so that we have a dedicated plan on where to go. So like a bit of a hurdle. I've been putting it off. I need to do the same thing for Laye at some point. Lots and lots of docs. I've kind of started thinking about it, but not doing it. Maybe we write docs on stream for either or both instead of writing code. Every time I start writing code, I just stop writing docs. And I am always writing code, so that's bad. But yeah, I'm going to call it here. There are links in the description if you want to come and join the Discord or check out my GitHub. We're not 100% synced here. We made a lot of changes. I'm going to carefully, let's see, git add, everything in lib is fine. Git add, include, everything is include is fine except for this one. That. So my test build script, my test refactor, source Laye, so add source, that's fine. Git add source. I don't know exactly what to call what we did. If you want to get your hands on the code, that's at my GitHub. Git add lib. Okay, yeah, that makes sense. Yeah, that's what dot does too, so yeah, that makes sense. I don't know why I didn't do that. I don't know why that never, yep, okay, never crossed my mind for some reason. Thank you. Okay, yeah. GitHub in the description, Discord in the description. If you want to come join, I'd love to come talk. love to talk when words. I need to go to sleep, goddamn. But that's going to do it for today. Thank you for joining me. Hopefully we'll get imports done the next couple of days. And Laye will be looking pretty good. Looking pretty good. So I'll see you guys next time. Bye-bye.